Hello, psychology students. This is Mrs. Politsky, and I have your notes for Module 9 talking about perception. And we're going to look at depth perception in this little section here. When we talk about depth perception, this is your ability to see things in three dimensions and to judge distance. And we rely on this ability to judge depth in three dimension when we're out and about on our doing our everyday things, like when we're driving and trying to make a decision whether to pull out onto a busy street or deciding when to pass another car. Our depth perception really depends on a lot of things, but it helps us guide like our hands when we catch a ball or to spike a volleyball or maybe even to shoot accurate free throws. It can also help us in threading a needle or wadding up a paper and tossing it into a trash basket or putting away dishes. And to test this, a couple of researchers developed what is known as a visual cliff. It was kind of a laboratory device to test depth perception primarily in infants and in small animals. And it was developed over 60 years ago by a woman named Eleanor Gibson and a researcher named Richard Walk. And this visual cliff basically ensures that a baby is going to be safe while allowing researchers to determine whether or not the infant can perceive depth. And so in 1960, they tested several small infants and were basically able to determine that if a child is a little reluctant to past the supposable edge of this table, um, then the baby probably is able to understand depth. And hence, that might be something that is an innate ability, meaning that we are born with that. When we talk about, this visual cliff, it kind of looks a little bit like this. You have a plexiglass that's been put across the table. Sometimes they will put like some patterns here. So we've got what looks like wallpaper or a tablecloth. And we're going to put the baby on the table. If they get to a point where they might perceive depth, they might stop, being afraid that they might fall down. If the baby is not perceiving that, they might continue across. And it was kind of determined that typically kids who are older than 6 months probably can understand where there is some kind of change as far as their perspective, and thus they can judge depth. So we're going to go back here a little bit. When we talk about the retina, it has a two-dimensional surface, and our brain kind of uses different tricks to kind of create three dimensions. Sometimes you'll hear about things that are in what we call binocular cues, which are basically when we determine depth using both of our eyes, or a monocular cue where we're determining depth only with one eye. And sometimes it all depends on what's going on. If something is coming into your field of vision, kind of in the peripheral, you're probably relying more on the monocular cues than if something is coming in your central field of vision where you might be using both eyes. So let's take a look at this. When we talk about how our eyes are set and we talk about stereophysis, this idea of using both eyes to kind of determining depth, for humans and primates, our eyes are set a little more towards the front, and this gives us a wider field of vision where we're using both eyes, and primarily the peripheral where we're using just one to kind of determine what's coming from maybe the left or the right, compared to some animals where the eyes are set more to the side. So rodents, maybe even horses and such, their center field of vision where both eyes might be working really is relatively small. It's the peripheral that they're relying on. And hence, that might make it easier for them to run away if they're being pursued by some kind of predator or something like that. When we also talk about, depth perception, we might talk a little bit about how we create this. And what you're seeing here is kind of an illusion that you might see if you would ever use kind of a um, what I would say, kind of like a ViewMaster, like you see here. What typically happens is on these slides, you have two images of the same thing, but relatively different. So I'm going to flip back here to our picture and Mount Rushmore. If you look at the images, they're just slightly different, not very much. But if we would use it through a ViewMaster and we kind of layer them, it allows this image to take on a little bit more depth, and it kind of looks three-dimensional. Looks like it's right in front of you. So, methods to create three-dimensional images. If you know anything about the old-fashioned 3D movies, people who were watching those wore these glasses where one eye had red, one eye had blue. And when you combine that, it kind of gives a little illusion. It's maybe not the greatest. You can have stereoscopic. This is kind of like using the ViewMaster idea, where you're kind of looking at the same thing relatively, and what ends up happening is you cross them over and you get this little depth here. If you've ever gone to the IMAX and you've watched a 3D movie there or gone to a 3D movie at the movie theater and they give you these polarized glasses, this is kind of the image that it's doing. One of the eyes is kind of seeing things more on the horizontal, the other is more of a vertical. And then when you put them together, it creates a little bit of an illusion that there's more depth there. So, so let's talk about binocular cues. This is done using what is called retinal disparity. And retinal disparity is this binocular cue that results from slightly different images being produced by the retina of the left eye and the right eye. And what you ended up doing is you combine those and you get the depth. Part of that is through this concept of convergence, meaning that the tension of the eye muscles allows for things to kind of appear that aren't really there. And a great example of this is what they call the floating sausage illusion. So if you would take your index fingers and kind of hold them about a foot maybe in front of your face, but not staring at the tip of your fingers. What you want to do is stare beyond that, maybe 10, 12 feet. What you might get is this illusion that the two fingertips have created a third finger that's just floating out there. And hence it's kind of known as the floating sausage. Part of that is because our eyes are staring further off and they're converging at a more distant point, causing this weird illusion to happen closer to you that isn't real because of the fact that your eyes are kind of focused elsewhere. So you can give that a try and see if that works for you. But that one is in your book if you need more help with that. When you talk about monocular cues, this is kind of what we do maybe in an art class. A lot of times you're taking something that's two dimensional and trying to give it a little more illusion that there's some depth to it. One eye alone can't use retinal disparity, can't do convergence. And so we have to use some tricks here to make this work on a two-dimensional canvas. And so we're going to kind of go through what these are, and then I'm going to show you some examples of this. But you got relative size. This is a pretty good monocular cue. The whole idea with depth perception, it's all about perceived size of an object. And if an object is known size appears to be larger, it's probably because it's supposedly closer to you on maybe a piece of paper and such. And thus things that are more in the distance appear smaller. Okay, so if I wanted to draw a painting and I wanted to put something, maybe make something look really big, I might put it closer to make it larger on the sheet of paper so it appears closer. And things that are way off in the distance, I might draw them very small. Relative motion. This is kind of perceived slowness, indicates that an object is way off into the distance. But if it's closer by, it might move faster. Sometimes people who have issues with car sickness, this relative motion thing can kind of get in the middle of that. But I'll show you some examples of that here in a bit. Interposition. Again, this is a cue that kind of works with relative size to a certain degree. It's obvious that when we talk about things that are close to us, they appear bigger, but they also have this ability to obstruct the things that are more off into the distance. And thus, you don't see those things maybe perfectly because it's covered by something else that's closer, supposedly closer, I should say. Relative height, distant things might appear higher up in the vision field. So if I was trying to draw something that's relatively small, I might put it higher up on the page to make it seem like it's further back. And the things that are closer might be a little further to the bottom of the page to make it appear that it's closer by. I'll also show you something with that here in a bit. Texture gradient. This basically says that things that are way off in the distance kind of appear smoother than things that are closer. Things that are closer, you're probably going to put more detail into that, and thus it's going to have a little more texture to it than things that are further off in the distance. Relative clarity, things that are, again, that are distant probably are a little more hazy. So if you've ever watched Bob Ross do some of his paintings, he has a tendency to kind of blur the things that are way off in the distance. He doesn't put a lot of detail into that. And part of that is to perceive that it's further off into the distance. Linear perspective, we talked about this in class the other day. You might remember this in some of your junior high art classes when you were drawing point perspective drawings. But this idea that we sometimes look at parallel lines, like at some point in time, maybe we assume that they intersect in the distance. Um, and thus, we can determine depth or create the illusion of depth from that. So, looking at some of these cues, when we talk about like relative motion, the perceived slowness, way off in the distance, and maybe what seems to be going blurring by really fast might give us an idea of maybe how far off something is. But at the same time, if you notice how these lines are going, if you're staring at something nearby and it's blurring by, and then you see this off in the distance, that might actually cause you to get a little motion sick. And sometimes that's a problem for some folks. Interposition, this idea that whatever is closest to you is going to kind of like, take on the concept of like the figure, and everything else is kind of in the background. This horse and its jockey kind of block everything that's off in the distance. And hence, if I were going to draw something like this, I might not put all the detail in with these other horses behind the number 7 horse, just so that people could perceive number 7 being closer. When we talk about relative height, we have our ducks here that are in a row. They seem to be closer. They kind of are big. Things that are way off in the distance, they are a little smaller. We know that houses are bigger than ducks. In this case, the duck is technically bigger than the house, but we're wanting to perceive distance. And then, we've got this barn way in the back. It seems small. And the fact that as things are getting smaller, they're kind of appearing higher up into the picture itself or on the page, to make it appear that it's way off in the distance. When we talk about texture gradients, this is a photo of the Black Hills. Notice the trees in the background. It's really hard to see the detail on these pines, but if you're a little closer to the bottom of the page, you can see kind of the basically the trunk of the tree and some of the branches. And so we would put more detail into the things that are closer by. All right. And relative clarity. Again, hazy off in the distance, more detail in the front, to make it appear that something is way off. When we talk about the linear perspective, the idea that it looks like we have this convergence. If I were going to draw this with a point perspective, I might put a point and then take my ruler and draw these straight lines. It kind of looks like at some point in time these rails are going to come together. But if you know enough about railroad lines, they run parallel. We can also create an illusion here. So we've got this, little rectangle here. As we move it back, the rectangle is the same size, but it's perceived to be bigger when we move it back, because the convergence here of this line perspective, it makes that rectangle seem much bigger than it is when it's in the forefront. So just some weird little tricks. Thank you very much.